Susan, and here's my video about my physics or calculations about the YouTube video of the jumper dropping off the big cliff on a rope swing. So here was our given information. We were given the initial height, or the height at which the jumper dropped, which was 130 feet, and the length of the rope was 150 feet. And we assumed that the mass of the human was 70 kilograms. So choosing our angle at 90 degrees, we applied the energy principle. So here we had Kf plus U equals Ki plus Ui, and we only have final kinetic and initial potential. So here's what we end up with. We plug in everything that we're given, and we end up with Vf equals the square root of 2gh, and this is our velocity at the bottom of the pendulum. So next we wanted to calculate the tension at the bottom, where the velocity was greatest. At the bottom, the tension is going to be greatest, and the velocity is also going to be greatest. So we said that F net equals F perpendicular plus F parallel, and since at the bottom there's no parallel force, we just know that F net equals F perpendicular, so we said F net equals mv squared over r. So we set this as if we know there are two forces, tension force and gravity force. So we have mv squared over r equals tension force minus mg. We plug in what we know. We use the radius as the length of the rope, which was 45.72 meters, and we get this as our final tension force at the bottom. And the next problem was to find the speed and the tension at a 30-degree angle. So here is our drawing. We know that when they go towards the bottom, they miss the ground by 10 feet. So we know that the height at 30 degrees is going to be the height of which we started plus the 10 feet, which is about 3 meters. So here we found the h to be the length of the rope minus the length of the rope times cosine of 30, which we have right here, and we found the height to be 6.125 meters. And so the height at 30 degrees, you would just add the 3.048 feet, and you get 9.173 meters. So then we applied the tension force yet again, and we found that mv squared over r plus mg cosine 30 is going to be the tension force at 30 degrees. Also, we used the energy principle to find the velocity at 30 degrees. So we did the same thing that we did previously. We set, except this time, since we're still in motion, we have potential final energy, kinetic final energy, and potential initial. So using all that, we found our final velocity. Now here, we wanted to find the stretch at the bottom. So we used our spring force because we wanted to treat the rope as an idle spring. So we said Ft equals Ks times S. We used the tension force that we got, and we found this spring constant on line 29,000. And here's our stretch. Also, we did the stretch at a 30-degree angle. So we applied the same thing, but we took our tension force, which we found right here, and found as 3.0521 meters. Okay, now I'm going to show you my code. Here we go. This code also shows the arrows of the perpendicular and parallel components changing as it swings as a pendulum. This code is also representative of an ideal spring. Now also we can show what we found. We printed the final position, final velocity, and the parallel and perpendicular components of F net, which we found to be pretty similar. Also, we can solve the parallel and perpendicular components analytically. We know that F net equals F parallel plus F perpendicular. We also know that F net equals F tension plus F grav, so we can set these equal to each other and solve. Thanks so much, and I hope you enjoyed the video.